All right, so we've seen that functions are pretty useful, but most of what we're doing in this class and as data scientists is working with tables, working with large data sets. How do we apply a function to a table? How do we use it to work with the information in a table? So here's an example of where we might want to use a function with a table. I've got my data set of NBA players, and I want to do some analysis, like ask what's the most common first name among NBA players. Well, there's no table method called dot player's first name. Okay, I have to code this up myself. I have to make a custom function to do this. And in fact, we've already made such a function that takes in a string and outputs a person's first name. So how do we take that function that we wrote and use it with our table? I mean, the first thing we could do is just get every individual entry in our table and apply our function to each individually. So how do we get, for example, the first player's name? Well, we get the player column, and then we use iloc 0 to get the first player's name. And the first player's name is Paul Millsap. Remember, we wrote this function before, first name, that you pass in a string that is somebody's name, and it returns their first name. And so we can pass in, for example, Paul Millsap, and we get Paul back. We could pass in the second player's name. Second player turns out to be Al Horford, and so we get Al. Or we could do the third player's name, and we get Tiago for Tiago Splitter. So this would work. It's just kind of obnoxious to have to do this over and over and over again. There's got to be an easier way. And of course there is. The easier way is called dot apply. So it's a series method that takes in a function and applies the function to all of the entries in a column. So the way that we do this, here's the recipe. We take our table, get the column that we want to use as the input to our function, and then we dot apply the function to that column. Then pandas, or baby pandas, takes that function and runs it on every entry in that column, and it gives us back a new series with the results. So here's that in action. I've applied my function to the entire column, and you see that it's returned the first name of all of the players. Now, something to keep in mind here, something to note, is that when we call apply with our function, we just pass our function by name. We do not use parentheses after the function. Okay, you might have gotten into the habit of every time you write a function, afterwards you're writing parentheses, maybe with some arguments. And we're not going to do that here. Having the parentheses, adding the parentheses after a function name calls the function. And we don't want to do that. Remember, the functions are like recipes. Just giving the name of the function is just like passing the recipe. But giving the name of the function with parentheses is like actually executing the recipe, and we don't want to do that just yet. Pandas is going to do that for us. So don't include the parentheses after the function name when using apply. Okay, so let's complete our analysis. What are the most common first names in the NBA? So to do this, I'm going to create a new table which has that new column in it, the column of first names. So to do that, I'm using dot apply, as we did on the previous slide, and then we're dot assigning that back to the table. Okay, so this creates a new table. I'm calling it with first names. You see, here's our new column. Now, how do I figure out which of these first names is the most common? We already know how to do this. You can take a second and think about it. Yeah, it's what we learned last week, group by. So if I use group by here, I'm going to group by first name. I'm going to count how large each group is, and then I'll sort to make it easier to figure out whose first name is most common. And what I see is Chris is the most common first name, followed by James, and then Kyle, and so forth. It'd be interesting to see Jordan. Jordan's a very common first name, but I wonder how many of these people are named after Michael Jordan. Like if this name became more common because of Michael Jordan. I don't know. Might be kind of cool. Okay, so here's another instance of a place where I might want to use a function with a table. And this is this task here is what we might call data cleaning. I have a data set that I'm just kind of artificially creating here, just making up. It's a data set of names and ages. So it's a excuse me, it's a miniature census. What I might want to do is replace all of the people who are above 100 years old with replace their age with just 100. Now, why might I want to do that? There's a lot of different reasons. Here's one of them. For example, suppose I want to do some analysis that says what's the most common name for every age. Well, for people, like if I look at 40 years old, there's going to be a lot of people in the data set who are 40 years old, and I'll be able to get a fairly good indicator of what the most common name is. However, if I go up to 110 years old, there's going to be like one or two people, and so by default they will be the most common name, and that's not really what we believe is a good, kind of indicator of what the most common name of 110 years old, of people who are 110, is. So what we'll do is, in order to get enough data for people who are that old, we will lump all of the people above 100 years old together. So to do that, we're going to apply a function which turns 106, 102, and 115 into 100. So here's such a function. What we do is we take in an age, and then we return the minimum of that age and 100. So if you think about it for a second, this will do what we want it to do. If the age that we put in is 42, it'll return 42, because 42 is the minimum of 42 and 100. But if we put in any number that's 100 or above, we'll get 100 back. So if you plug in 117, you're going to get the minimum of 117 and 100, which is 100. So we want to take this function, apply it to everybody in our census, and then create a new column with this cleaned data. So I've defined the function here. Now I will apply the function. I'm going to get a series back, and it has exactly what we want. The people who are over 100, their age has been truncated to 100. And then I'll save these results back into the table with a sign. So I have a new column here called cleaned age, which is exactly what we want. Now, if you wanted to overwrite the age column, you could do that too. Instead of giving it the name cleaned age, you could just call it age. And you see that that overwrites the old column. It overwrites it in the sense that we're creating a new table here. So the old table still has the old column information in it. Okay, so quick discussion question. We don't always use functions or applying to clean the table somehow. Here's an instance where we're not. If the name of a table is top movies and the name of a column is title, how do we find the length of each movie title? So which one of these would do that? You can pause the video and think about it, but I'll go ahead and give you the answer here. So we want to get the name of, or the length of every name of each movie. So to do that, I'm going to get the movies. I'm going to .get the title column, and then I want to use apply. And it looks like this one is most similar to what we've written before. This one's no good because we're calling the function. We don't want to call the function. These are no good because, well, apply just takes the function name. The column is specified with .get. So apply is a method on series, on columns. Len, L-E-N, is a built-in function, so it's not one that we've defined. It's okay, we can apply built-in built-in functions as well. So let's try it. If I remember correctly, there's a data set, topmovies.csv. So we'll read this in. Okay, and this is our table of top movies. So we'll just save this. Okay, and now we will write the code for option B, topmovies.get the title column, and then to the title column we will apply the built-in function len. What this is going to do is apply the function len to each of these strings. And you remember len, so if I run len on a string, it'll tell me exactly how many letters or how many characters are in that string. So I run this, it'll tell me the length of every movie title. So you could do something here, I don't know, you could figure out which movie studio releases movies with the longest titles and things like that. So here's an aside, a quick aside. What if the movie title had been set as the index? So what if this were my data? Okay. Now this is different than what we did on the previous slide because the title was a column in the previous data set. Now it's the index. Remember, the index is separate from the columns. It's its own sort of thing. Now how do we work with the index in this situation? I want to apply a function to everything in the index. So here's the code I might try to run. I might try to run, let's try this. I'm just going to create a new cell here to try to run it. So I might try by title, and instead of getting a column, I'll get the index like this. And then I'll try to apply len and see what we get here. It says index has no attribute, apply. What it is telling us is that there is no such thing as apply. There is no apply method for the index. The index isn't a column, so it doesn't have apply. So what do? We still want to do this analysis. How do we do it? Well, the trick is we'll take the index and move it back to a column. And we can do that with a method called resetIndex. So we take our table. It's got this as the index, but we want to make it a column. That's easy enough. We use resetIndex. That takes the index and makes it a column. Let me just show you that. So here's our table. I want to move this to its own column. I .resetIndex. And what happens is the old index becomes a column, and then the new index is just the default numbering. So that's useful here because now that I've made this a column, I can use .apply on this column. So I reset the index, I get the title column, and then I apply my function, and I get the same result. So resetIndex is a useful thing to keep in mind. It takes the index, moves it back to a column.